Hello and welcome to the Helm for Absolute Beginners course. In this course, we will learn how to manage Kubernetes applications using Helm. If you are wondering what Helm is, then Helm is the package manager for Kubernetes. It has a similar role compared to Yarn and npm for Node and pip for Python. So we know that with Yarn and npm we manage Node packages, with pip we manage packages for Python, and with Helm, we manage applications and packages for Kubernetes. That's why it is known as a package manager for Kubernetes. We will start this course by answering the questions: what is Helm and why we need it? Then we will learn about Helm charts, chart repositories, Helm releases, and Helm revisions. And then we will move on to exploring working with the Helm CLI for installing Helm charts, customizing chart installations, upgrading and rolling back Helm releases, and more. In this course, we will make complex concepts easy to understand with the help of animations and illustrations. Additionally, we will get hands-on experience by working with the terminal to practice working with the Helm CLI. So I hope that this course will be helpful for you, and I hope that you will have fun watching it. In this lecture, we will answer the questions: what is Helm and why we need it? We will start by answering the question: what is Helm? Helm is a package manager for Kubernetes, which simplifies and facilitates the process of deploying and managing applications within a Kubernetes cluster. It has a similar role compared to Yarn and npm for Node and pip for Python. So we know that with Yarn and npm we manage Node packages, with pip we manage packages for Python, and with Helm we manage applications and packages for Kubernetes. That's why it is known as a package manager for Kubernetes. The main purpose of Helm is to help you install, update, and uninstall Kubernetes packages and applications in a consistent, easy, and automated way. Let's move now to the second question: why we need Helm. So we will focus now on the problems that we had before Helm and how does Helm solve these problems. So we know that an application in Kubernetes might have different objects such as deployments, services, persistent volume claims, persistent volumes, secrets, config maps, and more. Each object needs its own YAML file for its configuration. We can put the configuration for all the Kubernetes objects in a single YAML file, but this is not ideal and not recommended. Although these objects are part of a single application, Kubernetes does not consider them as a group of objects part of the same application and manages each object independently from the others. For example, when deploying this application into a Kubernetes cluster, we create the objects one after the other by executing the kubectl create command followed by the name of the YAML file for each object. The same when updating or deleting the application, the Kubernetes objects part of this application are treated separately, and this makes the process of deploying and maintaining applications in Kubernetes a boring and tedious task. Helm solves these problems and reduces this complexity through the concept of Helm charts. It makes the process of managing applications in Kubernetes easier and faster, as it treats a collection of files part of an application as a single bundle known as a Helm chart. A Helm chart is a collection of files that defines the structure and the configuration of a set of Kubernetes objects that are part of the same application. With Helm, deploying application having hundreds or thousands of Kubernetes objects is as easy as executing the Helm install command. To deploy the application into a Kubernetes cluster with Helm, we execute the Helm install command followed by the release name and the chart name. The same chart can be deployed multiple times on a Kubernetes cluster. Each instance of a Helm chart deployed in a Kubernetes cluster is known as a release. For example, if we want to deploy the same chart again, but this time with our custom configuration, we can do that by executing the Helm install command again, but this time with the -f option to pass our custom configuration to Helm. So now two releases based on the same chart are installed. One is called My App and the second is called My Second App. Once a release is created, Helm gives us the capability to upgrade if a new version of the chart is available or if we want to change the configuration of the release. And that's done by executing the Helm upgrade command. And whenever an upgrade is done to a release, Helm keeps track of the previous version to allow you to version control your deployments and to roll back to one of the previous version when needed. So if something goes wrong in the upgrade, you can roll back to one of the previous version. Finally, whenever an application needs to be removed from your cluster, Helm simplifies the process and gives you the ability to remove the application with all its associated objects by executing the Helm install command followed by the release name. So that's a quick introduction to Helm. I hope that everything is clear. In the upcoming lectures, we will go deeper exploring Helm concepts and Helm commands. So that's it for now, and see you next time. In this lecture, we will talk about Helm components. We will take a closer look to Helm charts, chart repositories, Helm releases, and finally revisions in Helm. We will focus first of all on Helm charts. As we mentioned in the previous lecture, a Helm chart is a collection of files that defines the structure and the configuration of a set of Kubernetes objects that are part of the same application. It works as an instruction manual for Helm to know what objects to create, how they should be configured, and more. A chart is a collection of files and directories organized in a folder. We will go deeper in the structure of the chart directory and the content of the files and the directories later when we learn how to create our own Helm charts. Let's move now to chart repositories. A chart repository is a remote location for storing and sharing Helm charts. It is similar to GitHub for storing code and Docker Hub for storing Docker images. There are many chart repositories where you can search for Helm charts and you can make your own hosted repository, but the official chart repository that is part of the Helm project is the Artifact Hub repository. So with the Artifact Hub repository, you can search, share, and install Helm charts. Let's focus now on Helm releases. When installing a chart, a release is created. So a release is a single installation of a Helm chart. So anytime we install a chart in the Kubernetes cluster, a new release is created. For example, when installing the WordPress application by executing the Helm install command, a release will be created. While re-executing the Helm install command again with the same chart name, another release will be created. And the new release is totally different from the first one. So we can create as many releases as we want. Either these releases are based on the same chart or on different charts. Finally, we will talk about revisions in Helm. After installing a chart, over time, we may want to change the configuration of the application, so we may want to upgrade a release after its creation. And if the upgrade fails, we may want to roll back to the previous version. All of that is done through revisions in Helm. Whenever we install, upgrade, or roll back a release, Helm creates a new revision for that release. Each revision records the changes done for that release, and this provides a powerful version control for Kubernetes applications. So that's all for now. Thank you very much and see you next time. In this lecture, we will learn how to search for Helm charts using the Helm CLI by executing Helm commands. The first step when working with Helm is to identify the Helm chart that we want to install, because as we know, there are thousands of Helm charts available. We have two options for searching for Helm charts, either searching in the Artifact Hub website or using the Helm CLI installed on our system. In this lecture, we will focus on searching for Helm charts using the Helm CLI, and in the next one, we will explore searching for Helm charts in the Artifact Hub website. To search for a chart with the Helm CLI, we can use the Helm search command. If we execute the Helm search command with the --helm option, it gives us an accurate description telling us that the Helm search command gives us the ability to search for Helm charts in various places, including the Artifact Hub and the repositories that we have added to our local Helm client. That's why we have two subcommands that we can use with the Helm search command. Either the hub subcommand for searching for Helm charts in the Artifact Hub or in our hub instance, or the repo subcommand for searching for Helm charts in the Helm repositories that we have added to our local Helm client. Let's learn first of all about searching for Helm charts in the Artifact Hub. If we run the Helm search hub command with the --helm option, we get the description of this command. The description says that with this command, we can search for Helm charts in the Artifact Hub or in our hub instance. And to search for a chart, we execute the Helm search hub command followed by a string. In the bottom, we find also the options that we can use with the Helm search hub command. For example, for searching for MySQL charts, we execute the command Helm search hub MySQL. And in the output of this command, we get a list of charts. For each one, we get the URL of the documentation page of this chart, the chart version and the app version, which we will discuss more about them later when we learn how to create our own Helm charts, and finally the chart description. An important option that we will need a lot when working with this command is the list repo URL option, which can be used to get the URL of the chart repository to which the chart belongs to. For example, if we execute the Helm search hub command for searching for WordPress charts with the list repo URL option, for each chart we get the repository URL, which we may need if we want to add the repository to our local Helm client. Let's move now to the second option that we have for searching for Helm charts, which is searching in one of the repositories that we have added to our local Helm client. If we search, for example, for WordPress charts in the repositories added to our local Helm client, we get an error message indicating that there is no repositories configured. And that's because we didn't have any repository added to our local Helm client. We can verify that by executing the Helm repo list command, which will list the chart repositories that we have added to our local Helm client. So first of all, we need to add some chart repositories to our local Helm client. To add a chart repository to our local Helm client, we execute the Helm repo add command, followed by the name that we want to give to the chart repository, followed by the chart repository URL. For example, to add the Bitnami repository to our local Helm client, we execute the Helm repo add command, followed by the name that we want to give to this repository, for example, Bitnami, followed by the chart repository URL. We can find the repository URL either by executing the Helm search hub command with the list repo URL option, or by searching in the Artifact Hub website. If we execute now the Helm repo list command, we see that there is a chart repository available and it is called Bitnami. So whenever we want to add a chart repository to our local Helm client, we use the Helm repo add command, followed by the name and the URL of the repository. And to view all the repositories added to our local Helm client, we execute the Helm list command. After adding one or more chart repositories, we can search for Helm charts using the Helm search repo command. If the chart is not available, Helm will display the message "No result found" to tell us that there is no chart with this name available in the repositories added to our local Helm client. Otherwise, Helm gives us a list of charts with the name, the version, the app version, and the description for each chart. So that's all about searching for Helm charts using the Helm CLI. We will see later how to search for Helm charts in the Artifact Hub website. So that's it for now. Thank you very much and see you next time. In this lecture, we will practice searching for Helm charts using the Helm CLI. So we can search for Helm charts either using the Helm CLI or in the Artifact Hub website. And in this lecture, we will focus on searching for Helm charts using the Helm CLI. So to search for a Helm chart, we have the Helm search command. If we run the Helm search command with the help option, so here we get the description of this command. So here it says that we use this command to search for Helm charts either in the Artifact Hub website or in the repository that we have added to our Helm client. Okay, and for that here we have two subcommands. Either the hub subcommand for searching for Helm chart in the Artifact Hub or in our hub instance, or the repo subcommand for searching for Helm charts in the repositories that we have added to our Helm client. Okay, so first of all, we will focus on the hub subcommand. So if we run Helm search hub with the help option, so here we find that we can use this command to search for Helm charts in the Artifact Hub or in our hub instance. And here in the bottom we find the usage of this command, so how we can use this command. So if we want to search for a chart, we execute Helm search hub followed by a keyword followed by the options that we want to use with this command. And here are the options that can be used with the Helm search hub command. Okay, so for example, for searching for MySQL charts in the Artifact Hub, we can execute Helm search hub because we want to search in the Artifact Hub, and then followed by a keyword which is MySQL. So here we get a list of charts, and for each chart we get the URL of the documentation page of this chart, and then the chart version and the app version, and finally the description of this chart. And if we go, for example, to the documentation page of the first chart, so here we find the description of this chart, the prerequisites to use this chart, how we can install or uninstall the chart. With the Helm search hub command, we can use the list repo URL option to get for each chart the repository to which this chart belongs to. For example, if we search for WordPress charts, and here we use this option to get for each chart the URL of the repository to which the chart belongs to. So let's execute this command. So here, in addition to the URL of the documentation page, the chart version, the app version, and the description, we get for each chart the repository URL. And we will need this repository URL if we want, for example, to add this repository to our Helm client. Let's focus now on searching for Helm charts in the repositories that we have added to our Helm client. And for that, we use the Helm search repo command followed by a keyword. For example, if you want to search for WordPress charts in the repositories that we have added to our Helm client, we execute the Helm search repo command followed by WordPress. And it says that no repositories configured. And that's because we didn't yet added any repositories to our Helm client. So first of all, we need to add some repositories to our Helm client. And we can see the repositories added to our local Helm client using the Helm repo list command. So there is no repositories to show because we didn't yet added any repository to our local Helm client. To add a repository to our local Helm client, we need first of all to get the repository URL. And we can get the repository URL by executing the Helm search hub command with the list repo URL. For example, if we search for WordPress charts in the artifact hub and with the list repo URL, so here for each chart we get the repository URL. Okay, so we need this repository URL. For example, here we have a WordPress chart that belongs to the Bitnami repository. So if we want to add the Bitnami repository to our local Helm client, we will copy this URL and then we will add the repository using the Helm repo add command followed by the name that we want to give to this repository, for example, Bitnami, followed by the URL of the repository. So here we see that the Bitnami repository has been added to our local Helm client. And we can verify that using the Helm list command, so Helm repo list command to list the repositories that we have added to our local Helm client. So now we should see the Bitnami repository. So now we can search for charts in the repositories added to our local Helm client using the Helm search repo command followed by the chart name or a keyword. So if the chart doesn't exist, for example, if we search for a chart called my chart, so here we get no results found because there is no chart with this name. But if the chart exists, for example, if we search for WordPress charts, so here we get a list of charts. For each one, we get the name, the chart version, the app version, and the description of the chart. Okay? So that's how we can search for Helm charts using the Helm CLI. That's it for now, and thank you very much. In this lecture, we will learn about installing Helm charts. After identifying the chart, we deploy the chart by executing the Helm install command, followed by the name that we want to give to this release, followed by a reference to the chart. We have seen that a release is a single installation of a Helm chart, so whenever we install a Helm chart, a new release will be created. For example, for installing the Nginx chart that belongs to the Bitnami repository that we have added to our local Helm client, we execute the Helm install command followed by my Nginx release, which is the name that we want to give to this release, followed by bitnami/WordPress, the reference to the chart that we want to install. By executing this command, a new release will be created. We can view all the releases that are deployed by executing the Helm list command. When we execute the Helm list command, we get a list of releases. For each one, we get the release name, the namespace to which this release belongs to, the current revision number. We have talked about revisions and we will talk more about them in the upcoming lectures. We get also the last time this release was updated, the release date, the chart version, and finally the application version. Instead of specifying the release name when executing the Helm install command, we can use the generate name option to tell Helm to generate a name for that release. For example, when executing the Helm install command followed by bitnami/nginx with the generate name option, Helm will create a new release based on this chart and will generate a name for that release that will be displayed in the output of the Helm install command. So now if we list the releases that are deployed, we should see two releases. Both of them are based on the Bitnami Nginx chart. We can view the manifest file of the resources that will be created when deploying the chart using the dry run option set to client when executing the Helm install command. For example, when executing the Helm install command followed by the release name and the chart reference with the dry run option set to client, we should see the configuration of all the resources that will be created, but for simplicity we display here just the first part of the output of the Helm install command. With the dry run option set to client, the Helm install command will simulate an installation of the chart without really installing the chart and without creating any object. And of course, we can create different releases based on the same chart or based on different charts at the same time. For example, here we create a new release called WordPress app based on the Bitnami WordPress chart. So if we list the releases again, we should see 3 releases. 2 releases are based on the Bitnami Nginx chart, and the third one is based on the Bitnami WordPress chart. We have other options that can be useful when working with the Helm install command. For example, the atomic option to delete the installation if the installation process fails, the create namespace option to create the namespace if it doesn't exist. We have also the repo option to give the chart repository URL if the chart repository was not added to the local Helm client. and we can view all the options that can be used with the Helm install command by executing the Helm install command with the help option. After installing the chart, we can check the state of a release by executing the Helm status command followed by the release name. For example, to check the state of the release called my Nginx release created previously, we execute the Helm status command followed by the release name. When executing this command, many details about this release will be displayed, including the last deployment time, the namespace in which this release lives, the state of the release, the current revision, and additional notes provided by the chart. In case we want to view the resources part of a specific release, we execute the Helm status command with the show resources option. When using the show resources option, in addition to the information we have talked about earlier, the Helm status command will show you all the resources that are created when this release was created. And we can view the manifests of these resources by executing the Helm get manifest command followed by the release name. So that's all for now. I hope that everything is clear, and see you next time. In this lecture, we will practice working with the Helm CLI, and we will see how to install Helm charts. So whenever we want to install a Helm chart, we can use the Helm install command followed by the release name and the chart reference. For example, here we have added the Bitnami repository to our local Helm client. We can verify that using the Helm repo list command. So here we have the Bitnami repository added to our local Helm client. In this repository, we have an Nginx chart. So if we execute Helm search repo Nginx, so here it will search in the repository added to our local Helm client. We see that we have 3 Nginx charts that belongs to the Bitnami repository. Okay. So for example, we will try to install the first chart. Okay. The Bitnami/Nginx chart. We have also here the Bitnami Nginx ingress controller chart. And we have also the Bitnami Nginx Intel chart. Okay. For us now, we will use this chart. So to install this chart, I will execute Helm install followed by the name that we want to give to this release. For example, Nginx release followed by the chart reference. So it will be Bitnami/Nginx. So this command will create a release based on the Bitnami Nginx chart. Now the release was created successfully, and if we list the releases that we have now using the Helm list command, so we see now that we have only one release, and it is called Nginx release as we specified in the Helm install command, and it is created in the default namespace, and the current revision number is 1. And we have here the last time we update this chart, the state of the chart name, and the application version. Okay. Of course, we can create different releases based on the same chart. So for example, here we can create another chart based on the Bitnami Nginx chart. But here we have to give a new name to this release. If we try to execute the same command, so here we will get an error because we are trying to use the same name to create another chart. I will call the release nginx release -2 followed by the chart reference, which is bitnami/nginx. So now a new release with the name nginx release -2 was created, and it is based on the same chart, which is the bitnami nginx chart. And now if we execute the helm list command, we should see two releases, okay? And both of them are based on the nginx chart. And of course, we can create different releases based on different charts. For example, here in the bitnami repository, we have a chart called WordPress. So if we search here for the WordPress chart, so here we see that in the bitnami repository, we have two charts with the name WordPress. The first one is the bitnami/WordPress chart, and the second one is bitnami/WordPress Intel. So let's try to create a new release based on the first one, which is the bitnami WordPress chart. So we will use the helm install command followed by the name that we want to give to this release, for example, WordPress release, followed by the reference to the chart, which is bitnami/WordPress. So now a third release was created, and it is called WordPress release, and it is based on the bitnami WordPress chart. We can verify that using the helm list command. So now we see that we have three releases. Two of them are based on the nginx chart, and the third one is based on the WordPress chart. With the helm install command, we can use the --generate name option to let Helm generate a name for our release, okay? So instead of specifying here the name of the release, we will specify only the chart reference, for example, bitnami/nginx. So here we will create another release based on the bitnami nginx chart, but we will not specify a name for that release. We will let Helm generate a name for that release, okay? And that's done using the --generate name option. So let's press enter. So here we find in the top of the output of the Helm install command, we find the name of this release. So here is the name generated by Helm for this release. And if we execute Helm list now to see the releases that we have, we should find 4 releases, 3 releases based on the bitnami nginx chart, and the WordPress release based on the bitnami WordPress chart. Okay, so here is the last release created using the Helm install command with the --generate name option. Okay, so whenever we want to let Helm generate a name for our release, we can execute the Helm install command followed by the chart reference with the --generate name option. Another option that can be helpful when working with the Helm install command is the --dry run option. So for example, if we want to simulate an installation of a chart without really install the chart, we can execute the Helm install command, for example. So I will call this release nginx release -3, and it will be using the bitnami nginx chart. But here we want to simulate an installation of the chart without really installing the chart. So for that, I will use the -- dry run option, and I will set it to client. Using this option, Helm will simulate an installation of the chart and will show us the configuration files of the Kubernetes objects that will be created if we install this chart. So let's execute this command. So with the -- dry run option set to client, here we will simulate an installation of the chart without really installing the chart. So here in the top of the Helm install command, we get the name of the chart, the namespace, the state, the version, and here we get also the manifest files of the Kubernetes objects that will be created if we install this chart. Okay, so here we find a network policy object. So here is the YAML file of the network policy that will be created if we install this chart. If we go here to the bottom, we get another object, and it is a pod disruption budget. So here is another object. Here we find a service account object, and here we find the YAML file of the secret that will be created when installing the Nginx chart. So here, Helm will simulate an installation of the chart and will show us the YAML file of the Kubernetes objects that will be created if this chart is installed. Okay? Here we give the name of the release. We call it Nginx release -3. And to confirm that this just a simulation of a chart installation, if we execute the Helm list command, we didn't see here the Nginx release -3, okay? Because the last release was not created. It is just a simulation of a chart installation, okay? We can also check the state of a release using the Helm status command followed by the name of the release. If we execute this command with the help option, so here we find the information that will be shown when executing the Helm status command followed by the name of the release. It will show us the last deployment time, the namespace in which this release lives, the state of the release, the revision of the release, the description, and the resources. Here we can see the resources, so the Kubernetes objects, and to see the resources or the Kubernetes objects created by this release, we have to use the -- show resources option, okay? And here we find the usage of this command, so we execute Helm status followed by the release name. And here are the options that can be used with this command, okay? So if we check the releases that we have now, so we have 4 releases. Let's check, for example, the state of the Nginx release. And for that, we will execute Helm status followed by the release name, which is Nginx release. So here in the top of the output of this command, we find the name of the release, the last deployment time, and the namespace in which this release lives. And here is the state of the release, and it is deployed. We can see also the resources or the Kubernetes objects that belong to this release using the -- show resources option. So here, if we scroll up, we find here the resources created when this release was created. Okay, so here we have a network policy, and it is called Nginx release. Here we find another object, and it is a pod disruption budget. Here you find a service account, a secret, and some other Kubernetes objects. Okay, so all of these objects are created when this release is created. Okay, and if we install this release, all of these objects will be deleted. And if we want to see the manifest files of these resources, we can execute the Helm get manifest followed by the release name, which is Nginx release in our case. So here we get all the manifest files of the Kubernetes objects created when this release was created. So here, first of all, we get the configuration of the network policy. So here is the configuration of the network policy that belongs to the Nginx release. And if we scroll up here, we find the pod disruption budget configuration. Then we have the service account configuration, the secret configuration. So we get the manifest files of all the resources or the Kubernetes objects that belong to this release. And finally, to install a release, we execute the Helm install command, followed by the release name, for example, followed by Nginx release to install the Nginx release. So if we list the releases now, so we see now that we have only 3 releases. So let's install all of them. So Helm install so followed by the name of the release. So finally, the WordPress release, so Helm install WordPress release. So if we execute Helm list now, we didn't have any release. So that's all for now. I hope that everything is clear. Thank you very much, and see you next time. In this lecture, we will learn how to customize the Helm chart installation by overriding some chart parameters when installing the chart. With Helm, we can change the way the chart will be installed, and we can also deploy the same chart multiple times in different ways. And that's what we will learn in this lecture. For that, we need first of all to know the configurable options for the chart that we want to install, and then we need to know how to change these options. To view the options that we can customize for a chart, we execute the Helm show values command followed by a reference to the chart. For example, we can view the options that we can configure for the Bitnami WordPress chart by executing the Helm show values command followed by bitnami/WordPress, the reference to the WordPress chart. So when installing the Bitnami WordPress chart, there are many options that we can customize. We can change, for example, the WordPress username, which will be used when we want to access the admin dashboard. By default, it is set to user. We can change also the WordPress blog name, which is set by default to user's blog. We have many options to override the chart parameters when installing the Helm chart. First of all, we will do that using the -- set option. When executing the Helm install command to install a chart, we can use the -- set option followed by a key value pair to override a chart parameter. For example, if you want to change the WordPress username when installing the chart, we execute the Helm install command followed by the release name and the chart reference with the -- set option followed by a key set to a value representing respectively the chart parameter, which is WordPress username, and the value that we want to assign to this parameter, for example, my username. In the output of the Helm install command, we notice that the username is now set to my username instead of the default value, which is user. If we want to set multiple parameters, we can either use the -- set option separately for each parameter, or we can specify after the -- set option all the parameters separated by a comma. From the output of the Helm install command, we notice that the username was overridden, and to check if the WordPress blog name was also overridden, we can either view the WordPress application in the browser, or we can send a request to the application using curl, and then we grab the title. If we set the WordPress username using the -- set option to an integer, the installation will fail and we will get an error indicating that the given value is invalid. And that's because it is expected to be of type string, but the given value is of type integer. To force string values and to avoid these kind of errors, we can use the -- string option when setting the chart parameter, which will convert the given value to a string before assigning it to the parameter. So if we install the WordPress chart again, and we set the WordPress username to an integer using the -- set string option, the chart will be installed now without any problem. In some cases, the value that we want to set to the chart parameter may be too long, or it can be generated dynamically by a script or another application. In this situation, we can store the value in a file, and then we set the chart parameter using the -- set file option to get the value from the file. For example, we can store the WordPress username in a file called username.txt, and then when installing the Bitnami WordPress chart, we set the WordPress username using the -- set file option to get the value from the username.txt file. When installing the Bitnami WordPress chart, a service for accessing the WordPress application will be created. We can view this service by listing the resources that are created when installing the chart using the Helm status command with the -- show resources option. The service will be by default of type load balancer, and it will have two ports, an HTTP port set by default to 80 and an HTTPS port set by default to 443. And we can verify that using the Helm show values command, and here we pipe the output to the NL command just to print line numbers. The type and the ports of this service are configurable, and we can set them using one of the options that we have seen previously, for example using the -- set option. But when we have multiple chart parameters to override, it is better to set all of them in a YAML file, and then we pass the YAML file to the Helm install command using the -- values option. So to override the service configuration, we can set the type and the ports of the service in a YAML file. We call it, for example, service.yaml, and then we pass the YAML file to the Helm install command. If we list the resources that are created when installing the Bitnami WordPress chart, we should see that the service is now of type cluster IP, and the HTTP and HTTPS ports are now set respectively to 8080 and 444. We can also pass the chart parameters that we want to override in JSON format using the -- set JSON option when installing the chart. Finally, we can view the values supplied by the user when installing the chart by executing the helm get values command followed by the release name. So that's all for now. I hope that everything is clear, and see you next time. Hello and welcome to this lecture. In this lecture, we will learn about customizing Helm chart installation. So we have seen that to install a chart, we can use the command helm install followed by the release name and the chart reference. First of all, to customize a Helm chart installation, we need to know what we can change for this chart. Okay, for that we have the helm show values command. So this command will tell us what we can change for a chart, the parameters that we can change when installing the chart. For example, if we execute the helm show values command followed by bitnami/WordPress, so this command will show us the parameters that we can change when installing the Bitnami WordPress chart. So all of these parameters can be customized and can be changed when installing the Bitnami WordPress chart. Okay, and these are the default values assigned to this parameter. Okay, for example, here if we search for WordPress username, so let's execute the same command and then we can grep the WordPress username. So here we see that we can change the WordPress username. By default, it is set to user. The same for the WordPress blog name. So I think that by default it is set to my blog. So it is WordPress blog name. So here we have the WordPress blog name parameter, and by default it is set to user's blog. Okay, so these parameters can be customized and can be changed when installing the Bitnami WordPress chart. And to see all the parameters that we can change or we can set when installing the Bitnami WordPress chart, we execute the helm show values command followed by the chart reference. So let's try to install a WordPress chart and, for example, change the WordPress username. So for that, we will execute the helm install command followed by the release name, for example, WordPress app, followed by the chart reference, which is bitnami/WordPress. And then we use the -- set option to set a parameter. Okay, and here we mention the parameter name, for example, WordPress username. And here I will set it to a very simple value, for example, new username, just to test customizing the Bitnami WordPress chart installation. So here, instead of user, the WordPress username will be set to new username. So we get this problem because we already have a release with this name, WordPress app. So if we list the releases using the Helm list command, so we find here that we have many releases. Let's install all of them. So first of all, we have the WordPress app. And then we have the WordPress app-2. And finally, the WordPress app-3. So now if we list the releases again using the Helm list command, so we didn't have any release, okay? Now let's execute this command to install the Bitnami WordPress chart and to change the WordPress username. So now the release was created successfully, and here we find the name of the release, the namespace in which this release is deployed, their version number, and here some information about the chart. And if we scroll down here, we find that the username is set now to new username, okay? So it is set to new username instead of the default value, which is user. And to view all the values supplied by the user when installing this chart, we can use the Helm get values command. So with the Helm get values command, we can see all the values supplied by the user when installing the chart, okay? So here, followed by the release name, for example, the WordPress app release. So when we press enter, here we see the user supplied values. We have set only the WordPress username, okay? If we have multiple parameters to set here, we can use the -- set option again. For example, to set the WordPress blog name. So let's set it, for example, to my blog. So we can either use the -- set option again for each parameter, or we can mention all the parameters separated by a comma after the -- set option, okay? So we can either use the -- set option for each parameter, or we can mention all the parameters after the -- set option separated by a comma, okay? For this release, we will change the WordPress username, and we will change also the WordPress blog name. But first of all, we have to change the name of the release, because a release with this name already exists in the cluster. So now a new release was created with the name WordPress app-2. And for this release, we have set the WordPress username and the WordPress blog name. We see here that the username is set to new username, and we can get all the values supplied by the user when installing the chart using the Helm get values command. And of course, followed by the release name. So for this release, we have set the WordPress blog name to my blog and the WordPress username to new username, okay? If we try to install or to create a new release, but for this one, we will set only the WordPress username. I will set it to an integer, for example, 1234. And I will change the release name to WordPress app 3. So here we get an error because the expected value for the WordPress username should be a string, okay? But here we are given an integer. So here we need a way to tell Helm that the given value should be taken as a string, okay? And for that we have another option, which is the setString option. So with this option, we tell Helm that the given value should be taken as a string, okay? Even if it is an integer, Helm should treat this value as a string. So now the release was created successfully, and here, thanks to the --setString option, the given value is treated as a string. Another way to customize the Helm chart installation is to store the value in a file and then use this file to set the chart parameter, okay? For example, here we can create a new file. I'm gonna call it username.txt. And here I will store the username. For example, I will store this value too long username. And now I will use this file to set a chart parameter, okay? So I will create a new release based on the Bitnami WordPress chart, and we'll change the release name. So WordPress app 4. And here we will use the --set file option. And here we use this option to tell Helm that the value of the following parameter is stored in a file, okay? And then here after the equal sign, we mention the path to the file. So here /username.txt. So now when we execute this command, Helm will take the value stored in the username.txt, which is too long username, and we'll set this value to the WordPress username. So now the release was created successfully, and if we scroll down here, we find that the username is set to too long username, as we mentioned here in the username.txt file, okay? And this option can be used when the value that we want to set to the chart parameter is too long, or when the value will be generated by another application or another script, okay? So in these cases, we can store the value in a file, and then we use the --set file option to set the chart parameter. If we list the resources created for the last release, which is the WordPress app -4, using the Helm status command followed by the release name, which is WordPress app -4 with the -- show resources option. So let's scroll up, and here we find that we have a service. It is a load balancer, and it is listening on the port 80 and port 443. Okay, so by default, when we create a release based on the Bitnami WordPress chart, a service of type load balancer will be created, and it will be listening on two ports, on the port 80 and on the port 443. Okay, and we can confirm that by executing the Helm values command followed by bitnami /WordPress, and here I will use the command nl. So if we go to the line number 542, so here we find the service section when we create the services. Okay, so here we have a service of type load balancer, and here we see that it listens on two ports, the port 80 and the port 443. Okay, what we want to do here is to change the service type. So instead of load balancer, we want it to be of type node port, and we want to change the HTTP port. It will be 8080 instead of 80. So we want it to listen on the port 8080 instead of the port 80, and on the port 444 instead of 443. Okay, so here we want to change the service type and the HTTP port and the HTTPS port. Okay, and here instead of changing all the parameters on the command line when executing the Helm install command, we can create here a new file. I will call it service.yaml, and here we will mention all the parameters that we want to change. Okay, so here we are in the service section. So here we will type service, and for the service we want to change first of all the type. So we want it to be of type node port, and we want also to change the ports. So for the HTTP port, it will be 8080 instead of 80, and for the HTTPS port, we want it to be 444 instead of 443. So now we will create a new release. So I will call this release WordPress app -5, and here we can set all of these parameters using this option. So here we mention the parameter name. So first of all, we have a service.type. So we will set it to node port. And then we have the ports. So first of all, service.ports.http. We will set it to 8080. And then we have service .ports.https. We will set it to 444. Okay. Now when we execute this command, so the service type will be node port, and the HTTP port will be 8080 and the HTTPS port will be 444. But instead of using this complex command, we can use the -- values option, and then we pass the YAML file where we set all the chart parameters. So here we will use the -- values option, followed by the YAML file where we set these parameters. Okay, so the YAML file is service.yaml. So here we tell Helm that for these parameters mentioned here in the service.yaml file, instead of using the default values, we want to use the values mentioned here. Okay, so for the service, instead of load balancer, we want it to be of type node port. For the HTTP port, instead of the port 80, we want it to be 8080. And for the HTTPS port, instead of 443, we want it to be 444. So let's execute this command. So now the release was created successfully. And here we have the WordPress app-5. Now, if we list the resources for that release using the Helm status command, followed by WordPress app-5 with the -- show resources option. So we see now that here we have a service. Instead of a load balancer service, we have an output service. And this service is listening on the port 8080 instead of the port 80, and on the port 444 instead of the port 443. Okay? And always when we want to see the values supplied by the user, we use the command helm get values followed by the release name. So here we find the parameters that we have set in the service.yaml file. So these are a few options that we can use to customize the Helm chart installation. Okay? And to see all the options that we can use with the Helm install command, we can execute the Helm install command with the -- help option. So here, if we scroll up, so here we have the -- set option that we have used earlier. We have the -- set file option, and we can also use the -- set JSON option to set chart parameters in JSON format. And here we have also the -- values option to set the chart parameters in a YAML file and then pass this file to the Helm install command. So that's all about customizing Helm chart installation. I hope that everything is clear, and thank you very much. In this lecture, we will learn how to upgrade a release to change its configuration when needed. We have talked about upgrades and rollback with Helm in one of the previous lectures. We have said that after installing a Helm chart, over time we may want to change the configuration of the application, so we may want to upgrade a release after its creation, and if the upgrade fails, we have to roll back to one of the previous versions. All of that is done through revisions in Helm. Helm creates the first revision for a release when it is installed, and then whenever we upgrade or roll back the release, Helm creates a new revision for that release. And each revision records the changes done for that release, providing a powerful version control for Kubernetes applications. So we will start here by installing a Helm chart using the Bitnami WordPress chart. We will call the release WordPress app, and we will override the WordPress blog name. So it will be set to first blog name instead of the default value, which is user's blog. So now the release has been created, and if we view the values supplied by the user when installing the chart using the Helm get values command, we see that the WordPress blog name is set to first blog name. We can also view the history of the release by executing the Helm history command followed by the release name. This command will display the revisions that are created during the life of the release. So now by executing the Helm history command followed by WordPress app, we see that the WordPress app release has only one revision created when the chart was installed. To upgrade a release, we use the Helm upgrade command followed by the release name and the chart reference. So we can use this command if a new version of the chart is released and we want to move to this new version, or when we want to change the configuration of the existing release. So an upgrade takes an existing release and upgrades it according to the information that we provide. For example, if we want to change the WordPress blog name of the release that we have installed previously, we can use the Helm upgrade command followed by the release name, which is WordPress app, the reference to the chart that we are using, which is the Bitnami WordPress chart here, followed by the -- set option to set the WordPress blog name parameter to the new blog name that we want to use, for example, new blog name. By executing this command, the release will be upgraded and a message will be displayed on top of the output of the Helm upgrade command to confirm that the upgrade has been performed successfully. To verify whether the new settings took effect or not, we can execute the Helm get values command, and now we see that the WordPress blog name is set to new blog name as we mentioned in the Helm upgrade command. If we view the history of the WordPress release again, we will notice that the release has now two revisions because a new one is created during the upgrade process. So what we have to know here is that every time we create a release by installing a chart, the revision number of that release starts with 1, and then whenever an upgrade or rollback happens, the revision number is incremented by 1. Whenever the upgrade fails or we are unhappy with the upgrade process for any reason, we can roll back to one of the previous revisions by executing the Helm rollback command followed by the release name and the revision number. For example, here, if we are unhappy with the new configuration of the WordPress app release, we can roll back to the first revision by executing the Helm rollback command, followed by WordPress app, the name of the release, and the revision number, which is 1. After executing this command, a message will be displayed confirming that the release was rolled back successfully. So if we list the revisions now using the Helm history command, we notice that a third revision was created during the rollback process, and if we list the user supplied value using the Helm get values command, we notice that we are back to the first value that we have set when installing the chart. So that's all about upgrades and rollback with Helm. I hope that everything is clear, and thank you very much. In this video, we will practice upgrading and rolling back Helm releases. So if we list the releases that we have now using the Helm list command, so we didn't have any release. We have already added the Bitnami repository to our local Helm client. So if we list the repositories added to our local Helm client using Helm repo list, so here we find only one repository, and it is the Bitnami repository. So now I'm gonna create a release using the command helm install followed by the name of the release. For example, I want to call it WordPress app, and I will use the Bitnami WordPress chart. So Bitnami/WordPress, and here I want to change the name of the WordPress blog name. So I will override the WordPress blog name using the -- set option followed by WordPress blog name, which is the parameter that we want to override. And I will set it to, for example, first blog name. So let's press enter to create the release. So now the release was created successfully. And if we list the releases now using the Helm list command, so now we have the WordPress app release. And if we check the values supplied by the user when installing this release using the Helm get values command followed by the name of the release, which is WordPress app. So we see here that we have overridden the WordPress blog name, and it is set to first blog name. We can also view the history of this release using the Helm history command followed by the release name, which is WordPress app. So now we have only one revision. This revision is created when we install the Bitnami WordPress chart. Here we find the revision number. Whenever we install a release, the revision number starts with 1. And then whenever we upgrade or roll back the release, this revision number will be incremented by 1. So now let's say that we want to upgrade this release because we want to change its configuration. Okay, for example, we want to change the WordPress blog name. So instead of first blog name, we want to change it to, for example, new blog name. For that, we can use the Helm upgrade command. So we have the Helm upgrade command to upgrade a release. So when we want to upgrade a release, we use the Helm upgrade command followed by the release name and then the chart reference. And here we have various ways to change, for example, the configuration of the release. For example, using the -- set option to change a parameter or to override a parameter. We can also use the -f option to provide the YAML file containing the parameter that we want to override. Here we will use the -- set option to change the WordPress blog name. So here we will use the Helm upgrade command followed by the release name, which is WordPress app, followed by the chart reference, which is Bitnami WordPress, and we will use the -- set option to override or to change the WordPress blog name. So here we have WordPress blog name, and it will be set to new blog name. So now the WordPress app release was upgraded successfully, and here in the top of the output of the Helm upgrade command, we see that the release WordPress app has been upgraded. So now if we see the values supplied by the user using the Helm get values command followed by the release name, which is WordPress app. So now the WordPress blog name is set to new blog name, okay? Instead of first blog name, the value that we are using when installing the chart, okay? And also, if we list the revisions of this release, we will execute the Helm history command followed by the release name, which is WordPress app. So now we have two revisions, okay? Because as we said previously, when we install the release, the revision number we start with 1, and then whenever we upgrade or roll back the release, this revision number will be incremented by 1. That's why now we see here that the WordPress app release have two revisions, okay? The first revision is created when we install the release, and the second one is created now when we upgrade the release. So whenever we want to change the configuration of an existing release, or we want to change the version of the chart used by this release, we can use the Helm upgrade command. And if the upgrade process fails for any reason, we can roll back to one of the previous release. And we can do that using the Helm rollback command followed by the release name and the revision number. So if we execute the Helm rollback command followed by the help option, so here we find that we can roll back a release using the Helm rollback command followed by the release name followed by the revision number. So for example here, if we are unhappy with this new revision, we can roll back to the previous one. And for that, we will execute the Helm rollback command followed by the release name, which is WordPress app, followed by the revision number. So here we see that the rollback was performed successfully, and we can verify that using the Helm get values command. So now the WordPress blog name is set to first blog name, which is the value used when creating the release. And also if we list the releases using the Helm history command, so now we have 3 revisions. And for the third one, here in the description, we find that we are rolled back to the first revision. So here we see that the revision number for any release starts with 1. And then whenever we upgrade or roll back a release, the revision number will be incremented by 1. Okay? So whenever we want to upgrade a release, we use the Helm upgrade command. And if we want to roll back to one of the previous version, we use the Helm rollback command followed by the release name and the revision number. So that's all for now. Thank you very much and see you next time. In this lecture, we will learn about creating Helm charts. So to create a Helm chart, we have the Helm create command. So to create a chart, we can execute the Helm create command followed by the name that we want to give to this chart. Okay, for example, my chart. So when we press enter here, Helm create a directory with a set of files and folders inside it. So we have two directories, the charts and the templates directories. And then here we have the .helm ignore, the chart.yaml and the values.yaml files. Okay. If we want to understand the purpose and the role of each one of these files and directories, we will go here to the Helm documentation. And then here, if we go to the chart template guide in the getting started section. So here we found the chart folder structure. So first of all, we have the templates directory, and it is for template files. Template files are YAML files with some dynamic properties. We will learn more about them just in a few minutes. So when Helm evaluates a chart, it will sense the content of the templates directory to the template rendering engine, and then it will collect the results of the templates and sends them to Kubernetes to apply them in the cluster. Okay. Then we have the values.yaml file. In this file, we store default values of the chart. Okay. And then this value can be overridden either when we install the chart or when we upgrade a release. Then we have the chart.yaml file. This file is used to store metadata about the chart, like the chart name, the description of the chart, the chart version, the chart type. So it is used to store metadata about the chart. And finally, we have the chart directory, and this directory is used to store charts that this chart depends on. Okay, and they are called subcharts. Okay. So now let's go back to VS Code. So what we have to know at this point is that only the templates folder and the chart.yaml file are required to start working with this chart. So I will remove the values.yaml file, the Helm ignore file, and the charts directory. So this is the content of the chart.yaml file. So here we have the IPR version, the chart name, the chart description, the type of the chart, and finally the version. Okay. If we go here to the templates folder, so here we have some YAML files. I will delete all of them. So now what we put here in the templates folder is the YAML file of the Kubernetes objects that I want to create. Okay. For example, here we want to create a chart, and we want, when we install this chart, a config map is created. Okay. So for that, I will create a YAML file here in the templates folder, and this YAML file will contain the configuration of the config map. So I will call this file message config map. So now here we will put the configuration of the config map. So we start with the API version. So it is v1. Then we have kind. It is a config map. Then here in the metadata section, so we will give a name to this config map. We will call it message config map. Then here we have the data section. In the data section, we will have a property called message, and we will store this message. This chart works fine. Okay. So now the YAML file of the config map is ready. Now we can start working with this chart. For example, we can install this chart. To install the chart, so we execute the Helm install command, followed by the name that we want to give to this release. For example, my chart release, followed by the chart reference. So here / my chart. Okay, so the path to the chart. Now let's press enter. So we see here that the chart was deployed successfully, and we can list the releases using Helm list. So now we have a release with this name, my chart release. Okay, and if we list the resources created when this release was created using the Helm status command followed by the release name, my chart release with the -- show resources option. So now we see here that we have only one object, and it is a config map. Okay, we can also get the config map using kubectl. So kubectl get config map. So here we see the message config map created by this chart. So our chart works as expected, but here if we try to create a new release using the same chart, we get an error. Okay, so let's first of all change the release name. Here we get this error because a config map with this name, message config map, already exists in the default namespace in the cluster. Okay, so here we need to find a way to change the name of the config map for each release. Okay, because here we have hard-coded the name of the config map in the YAML file here in the templates directory, and it will be always message config map. So whenever we try to create a release, the name of the config map will be the same, and it will be always message config map. So here the name of the config map should be unique for each release. Okay, and for that we can use the Helm built-in object. So if we go here to the built-in object in the Helm documentation, so we will find here that we have many built-in objects that we can use when working with Helm. For example, here we have the release object. So here using this object, we can access the name of the release, the namespace in which this release lives. We can check if this release is upgraded or is installed. We can check the revision number. We have the values built-in object. We will see how to work with this object later. We have also the chart built-in object, the subcharts object, the files object, and also we have the capabilities object and the template object. Here when creating a chart, we can work with the release object to guarantee that the name of the config map, for example, will be unique for each release. Okay, and we can do that by combining this name that we are giving here, the message config map, with the name of the release by accessing this property, the name property of the release object. Okay, and we can do that very easy by adding here a template directive. So a template directive starts with 2 opening curly braces and ends with 2 closing curly braces. Okay, and then here we mention the object that we want to use, which is the release object. So here we want to access the release object, and specifically we want to access the name, a property of the release object. So here we have .release .name. Now whenever we create a release using this chart, so the name of the config map will be message config map combined with the release name. Okay, so let's try that again. So first of all, if we list the releases now, so now we have the my chart release. I will install this release, so Helm install my chart release. Let's list the releases again using Helm list. So now we didn't have any release. Let's now create a new release. So I will call it release-1 followed by the chart reference, which is my chart. Okay. So now the release was created. If we see the resources created when this release was created using the Helm status command followed by the release name, so release-1 with the -- show resources option. So here we have the config map, and the name of the config map is now message config map -release-1. Okay, so as we specify here in the YAML file, so it is message config map combined with the name of the release. The same thing will happen if we create another release. So I will call this one my release-2. So let's see the resources. So now the name of the config map is message config map release-2. So always for any release, the name of the config map will be message config map combined with the name of the release. So this way we can confirm that the name of the config map will be unique for each release. But here we still have another problem. The problem is that whenever we create a release, always the config map will have the same message. Okay, so always the message stored in the config map is this chart works fine. So there is no way to customize the Helm chart installation. There is no way that we can use to change the message stored in the config map. Okay, and if we create another release, for example, so here if we try to create another release, I will call it release-3, and if we use the -- set option, for example, we set the message to a new value like so new message. So at this point, this option will not change the message stored in the config map. So here we want to be able to customize the Helm chart installation, and we want to make the user able to override the message property of the config map. And that's what we will learn in the next lecture. So that's it for now, and thank you very much. See you next time. In this lecture, we will learn how to make our chart customizable so we can choose the message that we want to store in the config map when we install the chart. If we go back here to the documentation of Helm, so here we see that when we create a chart, we have the values.yaml file, okay? And if we go here to the bottom, So we see here that the values.yaml file will contain the default values for a chart, okay? And these values can be overridden by users during executing the Helm install command or the Helm upgrade command, okay? So here, instead of hard coding, for example, the message here in the manifest file of the config map, here we can create a new file and we will call it values.yaml, and here we will store the default values for the chart. For example, here, instead of hard coding the message in the manifest file of the config map, we can store it in the values.yaml file, and then we access it from the manifest file of the config map, okay? And to access the values that we store in the values.yaml file, so here we will go to the built-in objects, and here if we scroll down, so we find that we have the values object, and using this object, the values object, we can access the values stored in the values.yaml file. So here, instead of hard coding this value, we want to use the values built-in object, to fetch the value given to the message property. So here, to access the message property, we start with the name of the object, which is values, and then the name of the key, which is message. So now, by default, the value given to the message property will be the value given to this property, which is called also message, stored in the values.yaml file. But this value can be overridden when executing the Helm install command or the Helm upgrade command. So now, if we create a release using this chart by executing the Helm install command, so let's first of all list the releases. So we will delete these releases using Helm install. So if we list the releases again, so now we didn't have any release, okay? Let's create now a new release using our chart by executing the Helm install command, followed by the release name, which is my release, followed by the chart reference. So we want to use this chart. So now a new release is created. To see the resources created when we create this release, we can use the Helm status command followed by the release name with the show resources option. So we have here a config map, and we can see the manifest files of the resources by executing the Helm get manifest command followed by the name of the release. So Helm get manifest followed by the release name. So here we have the manifest of the config map. So here is the message stored in the config map, which is this chart works fine, as we mentioned here in the values.yaml file. But this message can be overridden, so we can override the message stored in the config map. So let's create another release. So we will execute the Helm install command followed by the release name. For example, my release-2. And here we can override the message using the -- set option, followed by the property that we want to override and the value that we want to give to this property. For example, instead of this chart works fine, we want to store welcome to Helm. So now when we press enter, a new release is created. We can see the resources by executing the Helm status command with the -- show resources option. So we have a config map and we can see the manifest by executing the Helm get manifest followed by the release name, which is my release-2. So now instead of this message, which is this chart works fine, we have this message, which is welcome to Helm, stored or given to the message property. So when we install or upgrade a chart, by default, the message stored in the config map will be this message stored here in the values.yaml file. In our case here, the message is this chart works fine, but we can override this value when installing or upgrading the chart using the -- set option. So here we override this value when executing the Helm install command, and the same if we upgrade the chart by executing the Helm upgrade command. So we can override it by using the -- set option followed by the property name followed by the value that we want to give to this property. Okay? So that's all for now. Thank you very much and see you next time.